Welcome everyone to the Great Lakes Permaculture Design Collaborative.
We are a trio of permaculturists.
Rhonda Baird from Bloomington, Indiana.
William Faith from Chicago, Illinois.
Milton Dixon from Ann Arbor, Michigan.
We're teaming up to create a hands-on learning experience
that can catapult you into a regenerative practice of your own.
glpdc.info
will send you to the host of our next Permaculture Design Certificate course.
So today we're talking about water, and here with our permaculture flower we are looking at how water interacts with almost all of these again. Certainly with land and nature stewardship, and buildings always interact with water. A lot of our tools and technology can help direct or use water. Water is critical for health and well-being. It's implicated in finance and economics more than we are aware of usually.
Whenever we think of finances and economics, ultimately everything is predicated on natural resources.
And water is key. So it touches on quite a few of our petals in permaculture flower.
Even the culture around water, the way that we think about water, education and culture.
So when we think about water on the planet, it's helpful to get some images and some ideas about how much water there is on the planet, where it is, and how it's being used. So roughly there are 330 million cubic miles of water on the planet, but only about 2.6% of that is fresh water.
I really like how this globe sums up the idea of water. There's so much of it, but so little of it is actually useful for our purposes, for terrestrial life. And this just kind of gives us an image of where we sit in relation to all this.
Whenever I look at this, I just remember that this is the ultimate system when we're talking about systems thinking in permaculture. All systems that we talk about are a microcosm of this big system.
Yeah. The other piece of this is it's not just the blue that we see that is water, but it's also all of the green and all of the white that is part of the water cycle.
Yep.
So most of the water that we're going to be working with as permaculture designers is actually the water that's moving through the water cycle, which is only 0.75% of the water on the planet is cycling at any one time.
I think in looking at water from the perspective that this is a cycle that we participate in, it's not just something that happens around us. We rely on water and drink water, and water goes out of us too.
And the way we interact in that cycle does have great consequences, and we either enhance and support or impede and degrade the process. There's no neutrality on this. It's a dynamic system, and we can have great consequence or support for this system through what we do.
Right. So a lot of what we've done is interfere with the water cycle, which has water evaporating from oceans, lakes, and streams, also transpiring from plants, condensing, offering precipitation that is either going across as surface water or down, soaking into the ground as groundwater. And a lot of what we've done on the planet is pave and deforest and move from deeper rooted plants to shallow rooted annual crops and monocultures. So that has created a lot of challenges for us. As permaculturists, we're interested in maintaining a healthy water cycle, of returning it to abundance. So 14% of fresh water is in deep aquifers, which means it's sort of like fossil water. So you see a map of the Ogallala Aquifer, which is the largest aquifer in North America. We can think of it like fossil fuels. It's only accessible through going deep in with machinery. And then about 10% of our fresh water is in more surface level aquifers and water tables. Then there's 0.6% in the biotic community, so in trees and forests and grasslands and plants and animals. And then about half of that is in lakes and ponds, and then the rivers and the atmosphere itself. So there's a lot of water around us moving almost invisibly.
It's such a precious resource, and how do we treat it? Drinking water in the toilet, essentially.
Exactly. And then for design, we always have to ask, how do we mimic these systems or elements of these systems in our designs for maximum effect?
So here we are with what not to do.
Exactly. I'd love to point to these pictures. This was during a PDC that we were doing in the high desert in California back in 2008. As we were driving, my co-instructor Graham took a picture of this out the window. It was just a perfect example of poor design. You're talking about an area that gets 7 inches of rain a year, temperature extremes up to 117 for a stretch of 3 to 5 days a year. And this is an area where they were building a shopping mall. And with all of it, you can see that they're directing all the water away from the site. So you're just basically collecting all the little bit of rain that they do get and just channeling it out into the storm drain. Whereas if you were, if you had any consideration for the area that you were working in, you would want to harvest the water that falls on there rather than channeling it away. It's crazy.
It's a monoculture of the mind.
Absolutely.
And while this is an example of what we do when we shed water from the landscape, we also need to be aware of what happens when we put, more water than the landscape is used to into the landscape. Things like landslides or erosion could become a problem if we're not careful.
Mm-hmm. So we're always anchoring soil, shaping it to be able to handle the flows across the surface.
Right, and being mindful of the slope.
Slope and soil types.
Mm-hmm.
Yes.
So it was an exercise in a children's permaculture program that I have run before. And this is one of those examples of how water interacts with buildings or with tools and technology from the permaculture flower. So what we were trying to demonstrate in this exercise was all the different ways that you could catch and store water in or near the house. So the children had a good time figuring out what was going on in each room and how it connected with the system outside, the ecosystem outside, and how then they could change their behavior in their own homes. If things as simple as putting a bucket to catch the cold shower water or bath water before it heated up to the right temperature, and then using that to flush the toilet. That's a really doable strategy in almost any circumstance.
And this kind of awareness should be something that we all grow up learning and experiencing. It becomes part of the fabric of our lives rather than this thing that we're trying to impose as an afterthought, which is kind of how it's going now.
Mm-hmm.
Exactly. I look at this picture and I'm immediately jealous because I always ask myself, how is it possible that we leave school without this basic knowledge, of how systems function, how resources function, and our part in that cycle? It's just insane to me that I left school without knowing how plants grow, and so I look at this and it just gives me a lot of hope.
So these are pictures of 2 different permaculture design classes building swales. And you'll notice that one is rather narrow, and it was a very long swale, and the other one in the top right picture is actually quite a wide and shallow swale. They were built in different systems with different needs in mind. So that's part of the design of the earthwork, to collect and spread water. So I should tell you what a swale is. Essentially, it is a channel that is built to cut across the contour line of a slope, so it intercepts and spreads out the water and allows it to sink in. So engineers will call these contour infiltration channels. And what they do, because they're all at the same level, above sea level, they will take the water coming from upslope, gather it into the bottom of the swale, spread it out along with the contour line, and then sink it in to the ground below.
And this is something we'll talk about a little bit more in an upcoming presentation on earthworks, but this is essentially just really good passive design.
Mm-hmm. And then in the bottom right, we have an example of a rain garden, which is a slightly different earthwork, but again with the same idea of catching and holding water and allowing it to infiltrate into the soil below. Rain gardens often have a design component to clean the water up from the source. So chinampas, these are from Xochimilco. They were in Mexico City, an area of Mexico City. All of Mexico City was built like this at one point. And they're essentially raised beds above the surface of the water. And the advantage here is that Mexico City is in an area where they don't often freeze, but they can get down to freezing. And so for these areas, they're getting a lot of benefits from the water. They're getting sub-irrigation of their crops, but they're also getting frost protection because the water is absorbing the sun's light and heat and re-radiating that out at night to protect the plants.
They're also getting the benefit of the ease of transport by boat to gather the produce in these chinampas. There's also, I've seen parallel ideas using the same concepts, such as wicking beds, where there's maybe in a drier place where there's not as much water, but you have a water reservoir, and it's beneath the plants. They can then access that water as they need it.
You see this pattern repeated around the globe. So in South America there were waru, and in East Asia there are the rice paddies and other forms of growing next to or in water.
It's also worth pointing out that this is man-made earthworks, that these are actually constructed.
So water storages aren't always in the ground, but often they are. In this picture you see three different storages. There, on the right, there is a pond, and this pond is at Central Rocky Mountain Permaculture Institute in Basalt, Colorado. And if you look very carefully, you'll see a line coming that is extended down into the pond, and water is pumped up to a greenhouse that grows year-round, grows tropical, subtropical fruits. So it's useful, but it's also serving as a sanctuary or a biological reserve, and is available to all the insects, birds, lizards, everything that's in the system has access to this pond. So it is a haven for life. In this bottom picture, you actually see a watering tank that is in that greenhouse referenced by the pond. That tank is just a watering trough collecting water off of the roof. It's painted black so that it absorbs more of the sun's radiant heat and re-radiates it out. It's high in the greenhouse so that gravity can be used to feed the water in different places. And then the top left picture is actually in another little greenhouse where somebody took an old washing machine and put some limestone pieces on top of it and put fish in it, and is growing nasturtium and other crop plants in their greenhouse and getting the same thermal battery for their greenhouse.
What's interesting about this picture on the right to me is I'm noticing all the algae in it, and it sounded like, I don't know the specifics of this site, but it's a lower pond. It's kind of maybe acting as a catch for all the the fertility that would otherwise wash away.
That's right.
Can land in this pond, and then they can reuse it, pump it up to greenhouse, probably use it on their gardens or wherever they see fit.
Absolutely. And if you notice, there's a lot of biomass in the form of plants at the other end of the pond. So that's soil building in an environment that doesn't do soil building very quickly. So here on this slide we have different ways that we go about catching water off of roofs, different things we can do. So the two left pictures are a simple rain barrel system. This is on the Grand Mesa in western Colorado, where they don't get a lot of water. But this is also a permaculture educator's home, and so she wanted to show people how to do, simple rain barrel technology. So you see the diverter on the right that just goes into the downspout, and then the rain barrel, and then she can take the rain barrel water by gravity to plants in containers. And then you'll see the downspout continues off of the rain barrel, and that goes down into a cistern that is further down slope. So she has to pump that water back up, to use that water. On the right, we have a first flush system, which is sort of a Rube Goldberg way of cleaning water coming off of a roof, where the water comes down and the first 5 gallons go into the 5-gallon bucket, and that's the dirtier water coming off of the roof. And then once the 5-gallon bucket is full, a float valve from a toilet tank system is in there, and it pushes the larger PVC pipe over to the red funnel. And so the cleaner roof water coming down in the rain can go off into a tank. So one of our rules with water design and permaculture is to match the quality of the water to the use that's needed. So in this other picture where there's a plastic tank next to a big barn, they're using that water to irrigate their crops for a CSA. And because the water is being put out into the garden, it doesn't really need to be cleaned up. The metal roof is clean enough. They don't care if there's bird poo and pollen and dust in the water, because that's just nutrient to the plants.
What I think about when I look at rain barrels, that the amount of water that you capture off a roof is pretty staggering. 1,000 square feet gives you ballpark 600 gallons of water from 1 inch of rain. 55-gallon barrel, catching a portion of that is not going to last very long. And so it's always important to think about what comes next. These sources of water can be very useful, but knowing what happens after it's full is really important. And then also knowing that that amount of water can really be stored in the soil much more easily. This isn't the end of it, but just one aspect, and really tying into buildings.
And it's where we intervene for use ultimately. Where if we want to use that for drinking water or wash water or what have you, that's where these kind of catchments become useful. However, Mark Shepard has a riff on this where he talks about how for a lot of people a single rain barrel is a design failure. That it's at some point that's going to fill up, it's going to back up, and then you're going to have all this water pouring down by the foundation of your house, and it's going to turn into a nightmare. You really need to think that through. Just what happens after that barrel fills up? Where does it go afterward? And thinking of larger catchment scenarios.
Mm-hmm. Absolutely. So essentially, we're designing for a cascade of water.
Right.
So going down the water cascade, once we have captured our water, we've used it appropriately, with quality, and then reused it if possible, we have an obligation to clean the water up. And so what you see here are 2 examples of ways to clean and enliven water. On the left, you see a flow form, those are beautiful ways to circulate water in sort of this infinity shape at each level. And as it goes down to the next level, it's exposed to oxygen, which aerates it and keeps it healthy. And then on the right, you have a picture of a very simple gray water system, which is taking water from a shower and a laundry and a kitchen sink and cleaning it up using plants and aeration before it goes down into a garden system.
I always like to point out that water is pretty indestructible. You can get a lot of uses out of it. Secondary and tertiary uses as gray water, or running it through a constructed wetland system before returning it to the ground. So it's amazing how many uses you can get out of it.
The use that is coming out of it in these instances, it looks pleasing, And I'm sure it's very relaxing to sit by, especially the flow form.
So besides our home systems, we have responsibility to care for the water quality in the larger landscape at the broad scale. And marshes and swamps and wetlands of all kinds are needed in the landscape in order to care for our water and ensure that there is an abundance of good, clean, fresh water.
It's really amazing how much we've transformed the landscape, especially marshes, drain them so that we can put them to productive use. Whereas they were quite productive before, just we had no idea.
How to use what was there.
Right.
Exactly.
Yeah.
Or how what was there fit into the system that we use.
Yeah.
I always like to point out the bigger picture that this is the classroom. This is where we come to observe and learn how nature does it.
I know Indiana and Ohio have both lost 98 and 96% of their wetlands, respectively.
It's insane. That much has been lost. Then we have problems that come from that we have to solve.
That are expensive.
And it's just an example of linear thinking. It's, we only think of the next step, what's right in front of us, rather than thinking in systems. And these are the results.
Yes. So I'd like to see these return. And we're back with our permaculture flower. So today we talked about water, its availability to us, some of the places that we want to intervene when we catch water, store it, use it, and reuse it, matching the quality to the purpose that we're putting the water to, and then also our responsibility to clean water up before it leaves our systems and flows on to the next place.